Welcome back. Today we will be talking about polynomial functions of higher degrees. As you can see in this function, 2 is the leading coefficient because the x has the highest degree. The other 5, radical 2 and 5, they are just the coefficients of the function. So there are a few components of this chapter. First is the graphs. When we are talking about the graphs of a polynomial function, the graphs should be continuous function. So the first point that the polynomial functions, they always have a continuous graphs. So what is the meaning of continuous? Continuous means that the graph that has no breaks, holes or gaps. Now understand it very, very carefully because you will need this understanding even for calculus. This is the first thing that you need to learn in calculus as well. So when we are talking about no break, no holes or gaps, it needs a smooth curve. And we can also say the smooth curve is nothing but we can create this smooth curve without lifting the pencil or pen up. That is the basic idea. If you are able to construct a graph without even at any point without lifting the pen up, that graph is called a continuous graph. So whenever you see any graph or you have to sketch a graph, just think, do I need to lift my pencil up to graph this or not? So if it is a continuous function, it is a polynomial function. Now, a few other things. The graph should be smooth, rounded turns. Now, what does that mean? It means that we are avoiding those graphs which has sharp turns or maybe cusp, because we are not looking for the graphs which has a point, right? Which has a sharp points. For example, in the absolute value bar, it is a V-shaped graph. The vertex, it is sharp. It is not a polynomial function. Likewise, the piecewise function. Piecewise function, they are just the staircases, right? We have discussed that in the parent function as well. They are also not continuous function because the basic idea of the polynomial function that is that the function should be continuous. So it should go smoothly with the round turns and round curves. This is very crucial understanding for the polynomial functions. So you can write it down in your notebook or wherever you want to, that polynomial functions, it is continuous functions. So continuity is the requirement. It is a kind of a prerequisite, right? Okay, now let's build up on this. So for instance, if we have a function f of x is equal to x to the power of n, where n is an integer which is greater than 0, right? Because if n is 0, then it is just a 1, then the function will become a constant, isn't it? So that is why we are saying n is an integer greater than 0. So the idea is this: greater the value of n, the flatter the curve or flatter the graph will be near the origin. And how it will work, you will see with practice, with more questions that we will do, and how when we increase the power of n, how the graph will look like. For example, x squared, it's a U-shaped graph, right? But when you will graph the x to the power of 4, it will be a flatter graph. Let's see. So gray graph is the x squared and the black graph is the x4. You can see the graph of the x4, it is more flatter at the origin. So what we can conclude, when n is even, it touches the x-axis at the x-intercept, and when n is odd, the function crosses the axis at the x-intercept. When n is even, it will not cross the x-intercept, it will touch the x-intercept, but for odd, it will cross the x-intercept. We are taking the parent function as x squared in this case. if you want, and the basic function, parent function, that means we are looking all the functions from the perspective of x squared and x cubed. Now, there is a very crucial understanding that is the second part of this chapter, that is called the leading coefficient test. Now, this leading coefficient test, it is very important, but it is quite intuitive as well. So when we are talking about leading coefficient, we are looking for whether the polynomial function will rise or fall can be determined by the function's degree. That means whether the function is an odd function or the function is an even function, and also by how the leading coefficient is behaving. For example, the leading coefficient is a positive or leading coefficient is negative, right? For when we looked at the quadratic function, we said, okay, if x squared is positive, the function will be upward facing. U shape is upward facing. When x squared is negative, then the U shape is downward facing. So that is the same thing. The leading coefficient will determine the behavior of the function. So let's understand this. So in the first case, we have n is odd. That means the power is 3, 5, 7, whatever it is. So with the n, when n is odd, it will cross the x-intercept. And the leading coefficient, in this case, in the first graph, we are taking as positive, and in the second graph, we are taking leading coefficient as negative. So when as x approaches to infinity, f of x also approaches to infinity. You can see the graph is going up from the right hand side, right? So it says if the leading coefficient is positive, then the graph falls to the left and rises to the right, provided the leading coefficient is positive. But when the leading coefficient is negative, the graph rises to the right, rises to the left and falls to the right. Now, when we are talking about when n is even, for example, x squared, x fourth, and so on, and when the leading coefficient is positive, then the graph rises to the left and to the right. The same scenario with the when a leading coefficient is negative, then the graph falls both sides, right hand side and the left hand side, both. Because when n is even, it is behaving something like the parabola. When n is odd, it is behaving something like the cubic function. With the cubic function, it crosses the x-intercept. Right? Let's understand it a little bit in detail with one example. So let's take f of x is equal to negative x cubed plus 4x. Now let's analyze this function. There are different components of this function, right? So what is the highest power or the highest degree of this function? The highest degree is 3. That means it is an odd function. And what is the behavior of the odd function? We need to consider that by leading coefficient. Now the leading coefficient is negative 1. So highest degree is 3 and leading coefficient is negative 1. That means we are looking for the graph will rise to the left but fall to the right and falls to the right. And when we graph this function, this is how the graph will look like, and it will match with our description. It is just the parent, it is a transformation from the parent function of f of x is equal to x cubed. So if you know the two basic functions, the cubic function and the quadratic function, then you can figure out the shape of the rest of the transformated function. So you can see it is rising to the left, but from the right, it is falling down. Right? And this is what we describe. So just by looking at the function, if you know the leading coefficient properties and the behavior, then you can write all the properties down. Let's take one more example. So this time we have f of x is equal to x to the power of 4 minus 5x squared plus 4. So let's analyze it. What is the highest degree? Highest degree is 4. So 4 implies it is an even function. And the leading coefficient is positive 1. That means it will rise from the right and it will rise from the left as well. So graph rises to the left and to the right. And we can see the same behavior when we graph the function. So this is how the graph will look like. Now you can see, you will say, oh, you said that it's a quadratic function. Yes, it is a quadratic function, but it is x to the power of 4. So x to the power of 4 function, it seems like a W-shaped graph because two curves, two parabolas, right? So that is why the function is like a W-shaped graph. There are other examples that we can talk about, and more examples with the cubic functions and maybe to the power of 5th or to the power of 6th, but the same pattern and the same behavior will go on. So the important thing is to understand the leading coefficient behavior. This is another graph. If you analyze this, it says the x cubed. So the leading coefficient was 3. So let's talk about real zeros of polynomial function. When we are talking about the real zeros of the polynomial function, we are talking about two different things. At most, we can get n real zeros, and at most, we can get n minus 1 relative extrema. That means the degree helps us to understand how many zeros that we can get and how many turning points we can get. When we are talking about the relative extrema, I have explained this in the another video as well. It is nothing but the relative max or relative min. When we talk about relative max and relative min together, that is called relative extrema. Now, a few things. Whenever you are solving to find the zeros, make sure that the equation is in the standard form. If it is not in the standard form, rewrite the equation again in the standard form and then start to factor it and find the real zeros. Right? Let's take one example. So we have negative 2x4 plus 2x squared. Now it is in the standard form. That means the highest degree first and followed by the least degree. So I know it is x to the power of 4. The graph should be somewhat a W-shaped graph, but it is negative, so it will be downward facing. Before we start, we need to understand that I can factor it out. So we can set, to find the zeros, we need to set f of x is equal to 0, right? So let's set it equal to 0. Negative 2x4, 2x to the power of 4 plus 2x to the power of 2 is equal to 0. Factor out negative 2x squared. We are left with x minus 1 and x plus 1 because it will be x squared minus 1, which is nothing but x plus 1 and x minus 1. So what will be the real zeros? Now watch carefully. We will have x is equal to 0, but x is equal to 0 is the repeated roots. Why it is the repeated roots? I will explain. You are writing negative 2x squared is equal to 0. We have two x's. So that means every x will generate 0. So there are two zeros, and this is called the repeated roots. And the another roots are 1 and negative 1. Now the second part of the question is how many turns could be there. That means how many relative extrema we are looking for. So maximum number of turning points will be n minus 1. That means the highest degree in the given function is 4. So n is 4. So we will use that n minus 1, which is nothing but 4 minus 1. So n is equal to 4. So 4 minus 1, that is nothing but 3 turning points. So at most we are looking for 3 turning points. And you can graph this on Desmos and see whether you are getting 3 turning points or not. So at most you are getting 3 turning points. Now in this particular problem, the function is f of x is equal to x cubed plus x squared plus 2. So the highest power is 3, right? So the n is 3. When n is 3, can I estimate how many at most the turning points will be? So it will be 3 minus 1, which is 2. So at most relative extrema we are looking for is 2 turning points, right? And then you can also estimate the real zeros. We will do another important thing after this, that is called the repeated roots. So that is the third thing. That is the fourth thing. The third thing was the real zeros that we just did. So the fourth thing is the repeated zeros or repeated roots. This is very important because often we overlook it. Oh, if it is x squared is equal to 0, x is 0. But the in-depth understanding is x has two roots, 0 and 0, because they are repeated. So if we have x minus a to the power of n, provided n is greater than 1, because if n is 0, or if n is a negative number, then it will become a rational number. So it will have x is equal to a of multiplicity n, right? This with the same example what we did earlier, that negative 2x squared is equal to 0. So highest power was 2. So it had repeated roots. That means 2 repeated roots. So the idea is this. When n, that means the degree is odd, the graph will cross the x-axis. We have seen that in the graph earlier. When the function is odd, it will cross the x-intercept. So x-intercept, that means it will cross the x-axis at x is equal to a. That is quite evident. We have seen it in the graph earlier. So the graph will go through the root. So the second scenario is when n is an even function. I think there is some glitch from my side. It will come. Here you go. So when n is even, the graph touches the x-axis. Remember, it will just touch the x-axis. It will not cross the x-axis. I have shown you the two graphs earlier when we started the video. If you don't remember, then go back to the video and see. So this is very, very important, that it will not cross the x-axis. It will just touch the x-axis at x is equal to 0. So when it is touching the x-axis at x is equal to 0, it is kind of bouncing back, right? Just like on trampoline, when you jump, you bounce back up and down, right? We are not oscillating. The main idea is what I'm trying to say is it will just bounce back. So just try to write these keywords. Try to create a story out of it, and it will stay in your mind for a longer period of time. So now the last important thing and very, very crucial is IVT, or intermediate value theorem. There is a big section of IVT in calculus as well. You will get a free response and multiple choice questions related to this topic. So this is a part of one of the existence theorem that you will learn in calculus. So for intermediate value theorem, continuity and the closed interval, these are the two prerequisites, right? So when we are talking about the continuity, I already told you that when we are talking about the polynomial function needs to be continuous function, right? And in this case, we are talking about the continuity. We are also talking about that the intervals should be closed intervals. There is no room for open interval for IVT. So it says something like this. If A is less than B, that means x1 is less than x2, the two coordinates of x. And it talks about the polynomial function. So polynomial function implies continuity such that the y values on these two coordinates are not equal, and these intervals are the closed intervals. A and B, they are closed intervals, right? So this is what the prerequisite is. Then f takes on every value between f of A and f of B. It will take every value, but IVT guarantees that there will be at least one value that will be there. one value n such that C will be in between A and B. So that is why understanding polynomials, understanding continuity, they are very crucial concepts, even though they are very tiny, but very crucial. So in two different graphs, sometimes in some of the books you will see graph number 1, sometimes in another book you will see the graph number 2. So f of c is equal to d or n. They are different ways of representing the same thing. Another important thing is what will happen if one of the y value is negative. So understand it. So if one value of y, that means either f of a or f of b, is positive, and the another y value, either f of a or f of b, is negative on the closed interval a and b, f of a or maybe f of b, right, just for understanding, and provided on the closed interval, then the function has at least one real zero. So the idea is if one y value is positive and another is negative, that means it will cross the x-axis. It will cross the x-axis at the real zero between, and that too in between the interval a and b. So let's look at this example. I have shown you this example earlier as well. So in this case, if you look at this function f of x is equal to x cubed plus x squared plus 1, here the intervals are closed. So what are the closed intervals? Intervals are -3, -2 and -1, right? And what is the intercept? Intercept, it is intercepting somewhere between -1 and -2. So that interception, that means the x-intercept, that is the real zero, and that is between the closed interval that we are looking for, f of -2 and f of -1. So f of -2 in this case is negative because we have a -3 value, and f of -1 is positive. So one y value is positive, another y value is negative. So that implies, and that too in the closed interval -2 and -1, that the graph, the continuous graph, will touch the x-axis at least one real zero. That is a very, very beautiful property of IVT. Right. So this is the teeny tiny analysis of IVT. We will talk about IVT in more detail when we will do the calculus part from this perspective. Till then, thank you.